So hello everyone, welcome back to the channel. So today we'll be solving a new problem, that is the lowest common ancestors of deepest leaves. So in this question we have given a binary tree, right? And we have given couple of things. So what we have to do in this question, so first understand that. So in this question the difficult thing was that to understand the question. So understanding the question was a bit like I think confusing or tough. So I will simply go into that, understanding the problem. So we have given the root of a binary tree, right? So if I'll show you the So this is the problem statement. So in the root, we have given the root of the problem. So like this, okay. And after that, what we have to do, we have to return the common ancestors, okay, of its deepest leaf. So what does that mean? So we'll simply first check that, okay, what is a leaf? So leaf means that, okay, if it doesn't have any children, it means that if it doesn't have any left and the right tree, then it means that this is a leaf node, right? So in that case, so if this is a leaf node, yes, this is 4, this is a leaf node, this is a leaf node, this and this, right? So these all are the leaf nodes, okay? Now, right? So now we know that, okay, so the leaf node is the node which doesn't have any children, okay? So this is the information that we got. And now the second thing is that we are talking about the depth. So in this case, we talked about the leaf node, okay. So in this case, the second one, we'll talk about the depth. So what is this depth? Okay, so depth is nothing that, okay, we can say the height or the levels. So in this case, what is the height? So for the root node it is 0, okay. So we have given that, okay, the depth of the root node is 0, okay. Now after that we will go to the next level. So this next level is the height would increase to 1. So this 5 and 1, their height is 1, and so on. Like we'll go below, we'll see that, okay, the height is increased to 2, and in the end the height is 3, or the depth is 3, right? So this is the second point that we are taking care of, okay. So now coming to the last, so this step is a bit confusing, so I'll share you with that the approach of that. So okay, so what we have given, so we have given the lowest common ancestors of a set S of nodes is the node A with the largest depth, such that the every node in S is in the subtree with root A. So speaking clearly is just saying that, okay, the lowest common ancestor, there are two things. So the first thing is we have to go to the largest depth. It means that we have to take the elements which are in the last level, right? Which have the largest depth, okay. And what it is saying, it is saying that the lowest common ancestor of S is the node A with the largest depth. So it means that the lowest common ancestor. So let's talk about the lowest common ancestor, okay. So what is the common thing here? So common means that, okay, if we have, suppose this is the suppose we are taking this node, okay. So the ancestor of this node would be its parent, right? So who is this parent? It's none other than 2, right? Okay. So for this 7, its parent would be 2, or we can say the ancestor would be 2, but we are talking about the common ancestor. So the common means that it's both the children should have the common, so like these two leaves should have a common parent or the common ancestor, right? So then we can say that this is the lowest common ancestor, okay. I hope I'm making sense. So the common means that common, what does common says? Common says that two things, right? Two things should be common, right? What if they are not? Then that is not the common ancestor. Suppose for this one, 5, right? So let's talk about this 5. So for this 5, we'll say that, okay, its children is this 6 and its children is 2. right? This can be the ancestor, okay? But we are talking about the lowest common ancestors of deepest leaf. Deepest leaf means what are the deepest leaf? So these are the deepest leaf, right? So is this the ancestor of this seven? It is, but not direct, right? This is not the common ancestor, right? So this two is the common ancestor of these two nodes. But this five, we'll say that okay, it can be ancestor of two, but this six is not a leaf. This is not a leaf. So it means that okay, it cannot be the answer of that because this is not the deepest leaf. It doesn't have any children. So it's on the level two, and this one is on the level three, right? So that's why this five cannot be the answer because of the six. Let's take an example. Okay. So for example, if this are six, right? Let's take this six. It have any value, suppose like 10, or let's take 9. Okay. Suppose it had value 9. Now we have, I'll draw the levels. So this would be level 0, level 1, level 2, and this would be level 3. Okay. Now let's talk about the ancestors again. Okay. So the common ancestor for this one should be 2, right? That's okay. And for this one, the common ancestor would be, I think, 6, right? Because we have another level that is level 3. So it has the deepest leaf. Yes, it is. So in these two cases, we'll say that okay, this is also the ancestor of the deepest leaf. This is also the ancestor of deepest leaf. So can this be the ancestor of the deepest leaf also? Yes, it will be because this one and this one, these two values are the deepest leaf. Okay. Then in that case, we'll go above. We'll say okay. So this is the deepest leaf. So we'll say that okay, we found the node that is having a deeper sleep. Okay, we'll go to 3. We'll check that okay, we'll have a deeper sleep here. Yes, we'll check for we'll ask the right one. Okay, so do you have the deeper sleep? We'll say that okay, we doesn't have any deeper sleep here. We have till level 2 only. We don't have anything on level 3, right? So we'll say that no. It say that no, we don't have. But it says from the left side, it says yes, we have. So we'll say that okay, if we have the left element, so this 5, so we'll return the answer as 5, right? I hope this makes sense. So now let's take another example to understand it clearly. So this example was very confusing for a lot of people. So before we talk about the third one, let's talk about the second one. So what the second one is saying that okay, when we have only one element, can this be the root or the deepest node? Yes, it can be because it is already a longest common ancestor of itself. Let's take, so in that case, suppose we have only one element, so every element can be the ancestor of itself because it doesn't have any children. So that means that okay, this is that can be the ancestor of itself. So this is the case that we have to take care of, right? Now coming to the third example. So this is the example 0, 1, 3, null, and 2. So I have drawn the binary tree of it. So right, I have added the levels here. Okay. So now we will see that okay, the answer is 2. Let's see. Level 0, 1, 2. Okay, it doesn't have any leaf. So this is the leaf element, right? So a lot of people were confused that okay, its ancestor would be 1. Okay. So people were like, okay, the answer should be 1. So do you also think the answer should be 1? Let's see that again. So this is really confusing and just pay attention a lot. Okay. So in that case, we'll see that okay, this is the leaf node. And we already know that okay, the single element can also be the ancestor of itself. Yes, it can be. Now, coming to the our main concern that okay, why this one is not an ancestor? common ancestor. So if we see that, okay, this one, it doesn't have any left children, right? For level 2, it doesn't have any left children. So we'll come to 2, that okay, we'll check for 2. We'll ask that, okay, are we the deepest node in the tree? It will say that yes, we are. We'll say that, okay, we'll say that to our parent that, okay, we have the values, like we are the deepest root. We'll say yes, we are. But it will go to the left part of it. We'll say that, okay, are you the deepest root? It will say no, we are not. No, we are not. The same example that we have seen it here. So it will ask the right node that, okay, are you the deepest root? It will say no. On the left one will say yes, we are. So we will return answer accordingly. Okay, right? So this was the reason why this one was not the answer, but this two was the answer. I hope I can understand clearly. Now coming to the intuition. So the intuition can be something that we have already seen, that okay, we will check for each node. We will check for three. We will go in depth. Okay, so we will simply use the DFS algorithm to traverse. You can also use the BFS one. Maybe I can do a video of BFS search for this question, right? So currently I'll focus on the DFS approach. So what we have to do, we will traverse through each element and we will also calculate the leaf node, right? And the depth. So for the DFS, we will start with the root node. So that is our zeroth one. Okay. We will check that, okay, DFS says that we have to, if we want to traverse, we'll just traverse in the depth. Like if we are traversing from the to the left, we'll traverse till the last element of left. Then we will traverse. Once we are done, then we will traverse the right part of the tree. So this is what the depth first search or the DFS means. Okay. So the same thing we will do. Okay, we'll start from zero. We'll say that, okay, we will move to the left. We'll move to the left, and we have to also take care of the depth. So currently we'll start with that. Okay, so our current depth is 0, right? And we are starting our node because we are starting with root, so our node would be root, right? These two things we are clear with, right? So we'll start with 0, that okay, this is the 0th depth. Okay, so we'll check, we'll move forward, so we'll move to the next element. So if we'll check that, okay, we have any left or right, so first we will move to the left. As you see that, okay, we'll move to the left first, then we'll move to the right. So these are the two values that we will start with. Okay, so our depth is currently 0 because the root depth is 0. So we'll move to the left first and we'll say, okay, we'll move to the 5 and we will increase our depth to 1 here. Okay, we'll move to the 5. Okay, so we'll check that, okay, do we have any left? We have any left, so we'll move, increase our depth to 2, right? Okay, so we're currently fine. Now the condition comes here, okay. So it will check that, okay, do we have any left or right of it? No, because if we'll go to the left, we will simply have none value or the nothing, right? Null value. So we will simply return the depth of it, so like 2. So it will say that, okay, do we have anything? It will say we have just nothing. We will return true. 2, okay. So it will say that, okay, we have the values and we will check that, okay, if both the values are same, like the depth are same, if both the depths are same, it means that, okay, it can be our subarray, not subarray, sorry. It can be the root value or the answer, right? Deepest value, because we haven't traversed the entire tree. So for us, this can also be the answer. So we'll say that, okay, this can be the answer. So we'll check that, okay, if our left and the right is equal, yes, it is equal. So we will simply return the node. So then our node is 6, right? Our node is what we will return? We will return our node, and the other thing is the depth. We'll say that, okay, we have a depth of 2 with the node value as 6. Okay, so we'll return it. We'll go to 5. We'll say that, okay, we have found something to the left. Tell me, do we have anything on the right? We'll say that, okay, if now for this 5, the what are the choices? Just think about it. If it has a leaf node of depth 2. Leaf node of depth 2. Okay, then we can say that okay, this can be the common ancestors. But if the value of the depth of the leaf is greater than this left value, then we'll say that okay, this is not the this left one is not the answer. So this right one will contain the answer, right? So that way we will check for this condition. Okay, so for this 5, we will check that okay, do we have any left, right? Yes, we have right. So it will go to 2. It will check that okay, do we have any left? Yes, we have left. Now this is the leaf node. So for the same thing, we will check that okay, now this will contain the depth as 3. So what we will return, because the depth of these two would be same, because this is 3 and 3, right? The null value will return just the depth of it, so it will return 3. So this is equal. So we'll say that okay, we have found something. So we have found the node as 7. Okay, the node as 7 and depth is 3. Okay, depth is 3. So we'll say that to the 2 that okay, we found a depth that is equal to 3 and we have a node. 2 will say that's good. Okay, that's good. Let's ask the right one. So do we have anything? We'll check that for 4. Okay, we have left. No, it will simply return the depth. We'll say that okay, we have the depth as 3. So what we will return? We will simply return the value. Tell me the node that is 4 and the depth is 3. So we'll return to 2 that okay, we found something. What we have found? We have found the value. We have found the value. 2 is will say, yeah, that's good. So what are the values? It will say that okay, the same thing that we have did here. So we'll check, say that okay, that what is the depth? If the depth is same, it will say yes, the depth is same. The depth is 3. It will say that's good. Then can this, think about it, can this be the common ancestor of it? We'll say yes, this will be the ancestor because this has uh, the length same, right? The length is same. So what the answer currently would be, we'll say that okay, the node value will return would be 2. We'll say that okay, this 2 with depth 3, right? This 2 value with the depth 3 because this is the largest depth, right? If we found any value greater than 3, we will say that okay, then this would not be the the longest common ancestor. Then the fourth one would be the longest common one. Okay, but currently this is the maximum one. So we'll store it somewhere, right? So now we will simply return this. So what we will, this 2 will return, it will return 2 comma 3, right? 2 is the node and it will return the depth. Okay, so it will come to 5 that okay, 5 will say what have you found? It will say we have found the value 2, which will give us the depth as 3. It will say ask the right of it. So it will ask to the left one. So what have you found? So it said we found only the value 6 with depth 2. But it will say, okay, we already have a depth that is greater than 2. And we also need the largest one, right? The lowest common ancestor of the deepest leaf. So the deepest one is 3. So it will say, okay, it cannot. Then 5 will say, okay, I cannot be the leaf. Sorry, I cannot be the lowest common ancestor of it, right? So now we will simply say that, okay, we cannot be that. Then we will simply increase our depth. We'll say that, okay, 5 will say who is the ancestor now? It will say this one is the ancestor because we this is the maximum value that we have, right? Why will this 5 will not change? Because this 5 is not matching the condition. We have only this ancestor, right? So the 5 will return us the value 2 and what was the depth? 3. But now when we are here, so we have to also tell to the ask to the right part of the 3 that okay, the 3 will tell us that okay, the left part is giving us the value 2 comma 3. Do we have anything greater than the depth 3? So it will ask that okay, if we have, we'll say that okay, we don't have. It will say that okay, we only have the depth 2, right? And the value can be anything like 0 or 2, whatever you take. Okay, it will say that okay, uh, sorry, the yeah, that was correct, I think. So the depth would be 2. So it will say that okay, 3 will say okay, I cannot also can also be not the depth common ancestor. So the our answer would be this 2 comma 3, right? I hope that makes sense. So I'll quickly code this up so that way you can understand it better. So first we will start with our DFS. Okay. So what this DFS is, we'll take two things. The first thing would be our node, the same thing that we discussed, and also our depth, right? So this we will fill it up. I'll currently pass it. And after that, what we have to do, we will simply take the value of this DFS. So what we will pass in the DFS, the root value, because this is the starting of it, and the root value is 0, right? And we will store it in some variable. So let's take this will return us what were we returning? The value of node. Okay, let's take node only. Node and also the height or the depth, whatever you wanna like. Okay. And we will simply return the value of node because this is the main thing that we have to return. Okay, we have to return the node value. Now, talking about the DFS. So, let's talk about the base condition. So, what would be the base condition? So, if we have null value, right? Suppose it is 7, we had the null value, then what we will do? We have null value, we will simply return the depth of it. Suppose the depth was here 3. So, we'll say that, okay, we don't have anything, just go back. So, it will say that, okay, our depth was because the depth won't increase, right? Because this is the null node. So it will say that, okay, we cannot increase that. And we'll simply return the value as 3 and with our null node because we don't have anything here. Okay. So then the condition would be if not node, then we'll simply return the value as, okay, we don't have anything, right? Because null node, we don't have anything. Just simply, we can't change the value of depth because it's nothing. Okay. So we are done with the condition. Now, we will use our DFS. So in DFS, we have to first move to the left, right? Then we will move to the right. Okay. Then we'll have some conditions here, some if conditions. Okay. Then we'll have some if conditions. So this is the basic thing of it. Now, to move left, we need two things, right? As in the DFS, we need two things. So when we were moving left, we were also increasing our depth. So if you remember that, okay, we started with 0. We move to the left, we increase 1. We move to the right, we increase one more value, that is 2. So what does that mean? So for that, I'll just simply first write the DFS of it. Okay, we'll move to the left, no dot left, right? And also we have to increase the depth. So we'll increase the depth because we are moving to the left and increasing the depth, right? The same thing that we will do to the right one also, right? We'll say that, okay, we'll move to the right part of it. And we'll also increase our depth here also because if you'll move to the right side, we also need 1, then we will need 2, right? Because it will increase our previous value, this depth plus 1. If this is 1, that would be 2. If this is 1, this will also be 2. So like that, okay? Now we'll take some variables that just left. So this node value would be, so let's take this is the left node, okay? This would be the right node. And we'll also have, it will also return the depth. So we can take that, okay? This is the left depth. And this can be our right depth. Right? These are the two things that we have. Okay. Now moving to the if conditions. So for the if conditions, we'll check what was the condition. The condition was if both of these are having the same leaf node, right? If it means that this is the common, this is the common ancestor, right? So this is what we will see there. Okay, if the left subtree and the right subtree, they are having the same leaf or same depth, okay, then this can be the common ancestor. So the same way I'll write it down here. Just take a look. Okay, so if the left depth is equal to the right depth, this is the same thing that we're discussing, right? It means that this is the node value, this can be ancestor. So we say that, okay, we will return this. What this 2 will return, that, okay, I am the ancestor now. Okay, I'm the ancestor now. It means that what is the current value? It can be anything like left node or right node. No, sorry. It can be the node, and the depth can be anything. Left depth or right depth. It doesn't matter because we are having the deepest leaf. Okay, so this is the level 3. So it will say that okay, we have our node 2 comma 3. So how we will return that? They'll say that okay, our current node is 2 because this is matching the condition, right? And after that we will simply return the value of depth. So this is the maximum depth that we have reached. Okay, now coming to the else conditions. For example, if that's not the case, we have seen that okay, in this 5 it was returning 2 comma 3, right? 2 comma 3, but what this 6 was returning, it was returning only the value 6 comma 2, right? So these depth was not matching. So for tell me which tree we will take, the left one or the right one. Think about it, because we need the lowest, I can say the maximum depth, so we'll take the maximum depth one. So if this is the left one is the maximum depth, we'll take the left one as an answer, or the current value. It will say okay, it will choose the left one, sorry, the right one. Okay, it will not choose the left one. So we will simply translate it into the code. So we'll check that okay, and if our left depth is suppose greater than the right depth, right? Suppose our left depth, or let's take it as an example. So our right depth is greater than our left depth. In that case, which depth we will take? The right one, okay? So we'll simply return that, okay? Return the right one, right depth. Okay, so we'll simply return the right node. And what would be the depth? The depth would be the right depth, right? And else in the last, we will simply reverse the condition. If that's not the case, if like the left one is greater, then we will simply return the opposite. We'll return the left node and also the left depth. I think this is the DFS. Okay, if I'll try to run it, let's see what I have missed. Nothing. Okay, so this is accepted, and I'll simply submit it. So as you can see, this is T efficient, and this is all submitted. And also talking about the time complexity of it. So the time complexity would be big O of n. Why? Let's see. We are just traversing the tree just once, right? We're just traversing doing the DFS just only one time, right? And we are not using any array or any storage. So that way our space complexity would be big O of 1, right? And our time complexity would be big O of n. So this is about the time and space complexity. So I hope you understand this question. So the same question we have, that is called the smallest subtree, right? I have already used the same code, and it is pretty efficient. And you can just go through this solution also, or the problem also, right? The smallest subtree with all deepest nodes. Okay, this is the same problem. It's just the words are changed, and also the examples are also same. So yeah, so this will cover both the questions. So I hope you understand this question, and if you have any doubts or any suggestions, just drop it in the comment section. And thank you for watching, and I'll see you in the next one. Bye bye. Take care.